This is going to be the data-driven decisions lecture. This is a shorter lecture because I normally have to give class time in order for you to go in and complete your measurements and to graph them out so that you'll have a visual representation for your template. One thing I want to remind you about, and I've reminded you over the past couple of lectures since the educational research one, is if you did anything or you took measurements that were health related, that like weight, girth measurements, you need to make sure that you report this individually and you do an individual template. I don't want your team members seeing your numbers. I just don't want anybody seeing your personal information. So if you did this and you used health related information, maybe you changed something in your diet or you started working out to change your numbers, and you took like blood pressure, weight, girth measurements, it doesn't matter if it's personal health related information. I want you to do this template individually and this lecture individually, or the lecture notes. So data-driven decisions, what are they? I use them to quantify your learning, and I also use them to quantify my teaching to see if I make changes to my plan, my lesson plan, does it impact your learning positively or negatively? You used it in developing your hypothesis in your experimental design. You also used it to create goals, to stay on task, to keep up with your experimental design. Common methods of data collection, we talked about empirical research and quantitative assessment. Qualitative would be something like a survey, something that's subjective, that asks you your opinion. Quantitative would be objective. What y'all did for your experimental design was all quantitative. You actually measured something. And then we're going to go back in and look and see what changes. So your common methods of data analysis, we didn't talk about this before, but addition would be, or sum would be adding up all the numbers. You have to do that in order to get an average or to get a mean. You add up all the numbers and divide by the number that you added up. I know y'all know this. Range of numbers is high and low scores. We saw that on the quiz results when I would come back and give you feedback about how you did. We would look at the high and low numbers and see where we were at on our normative data. And then your standard deviation is another popular one to see if everybody's scoring the same. Did anything change? You could, if nothing changed in your experimental design, you're going to have a standard deviation of 0. But you won't have to report that. I'm just kind of reminding you of important research methods or data reports. Data analysis, you're going to have to analyze and evaluate your data. And you're going to see if your hypothesis was correct. Did you accept the null hypothesis, or was your hypothesis accepted? So we're going to go back in and look at the data. So common methods of organizing data are going to be graphs, charts, normal curve like we would see in those quiz reports, data plots, like if we were looking at like a linear regression where the data plots are formed. And if you can draw a straight line between them, that's a perfect correlation. Or if they were all spread out, there's no correlation. These are all common methods that you would want to consider. Probably for us, the best thing is going to be a bar graph, and I'm going to show you how to do that in just a second. Hypothesis review. Review your hypothesis after you collect your data. Review your SMART goals and see if you actually achieved what you thought was going to happen. So maybe you were looking at plant growth and one plant got more water. Did the plant that received more water, was that your hypothesis that it would grow more, or the plant that received more sunlight grew more? Was that your hypothesis? And did it happen? Did you achieve your SMART goals? Did you stay on task and keep up with your experimental design to make sure that you had the chance of really testing your hypothesis? Continuous improvement. If your hypothesis was proven and your goals were achieved, I don't know why there's a T in there, how could your study be improved? How could you have done better? So this is focusing on continuous improvement. Even if you got what you wanted, how could it be improved? What did you learn from doing it? Is there a way we could have made this experiment better? If the null hypothesis, which is the opposite of your hypothesis, was accepted and your goals were not achieved, or one or the other, how can the experiment be altered? So either way, how can you improve? Did you achieve what you thought you were going to do? Did you stay on task with your goals? If so, how do you continue to improve? Or if you didn't, and the hypothesis was not correct, could you change something to cause it? Or maybe you were lazy and you didn't keep up with your experimental design. What could be changed to improve? That's what we want to talk about. Our improvement plan is going to be based on the results. We're going to look at the results. Did we get what we thought we would get? If not, how could we improve? If we got what we thought we were going to get, which is our hypothesis, then how could we make it better? So this is exactly how scientific research works with the experimental design and choosing qualitative measurements, quantitative measurements. Typically, it's going to be quantitative, especially if it's a really controlled, but you can use qualitative assessment as well. Qualitative, you're going to see more in education than you will like the hard sciences like biology and chemistry. They're going to be more quantitative. So now let me show you what we would do in class. We would go back to our experimental design. We would pull up Excel, or you can do this on Google Docs. Let's say we did the plant experiment. So plant 1, you can write in as much information as you want. You can give me more details after you do your graph. But just to do the graph, I'm going to write plant 1's measurements in one column, plant 2 in the other. I want to label them at top. So just do it exactly like I did. Then you're going to go insert, go over to bar graph. I would rather you have a bar graph here. And then you can get a chart. So now it lays out each one of those days. Plant 1 is indicated by blue, and plant 2 is indicated by orange. And then you can label your chart if you want to. So you can say group, whatever your name is, 1's experimental design, whatever, experiment. Right? So we can put that in there. Plan experiment, you can tell me that this is, you could go in and change these from day 1, day 2, whatever you want them to be changed to. You can make a lot of adjustments here, and you could even put more details down in here if you wanted to. Or you could do that inside your lecture notes. So let me pull up the lecture notes. So you would have answered these questions after the lecture, and then you would have graphed out your data. This just happens to be one that we did in class just to kind of show you some of the measurements we took. And then I would have taken this and collected it for the group. And this group happened to do pre-weight, post-weight, pre-systolic pressure, because when you do blood pressure, you're going to get systolic versus diastolic. They did a pre-resting heart rate, post-resting heart rate to kind of look at cardiorespiratory fitness. It's just one measure. It's not the best, but you can use it as a physical measure as well as a non-physical measure because you don't have to do anything to get it. Pre-waist versus post-waist. These are all things I would do in a kines class. And then pre-hip versus post-hip. These are girth measurements. They can be a measurement in conjunction with weight as body composition, or a measure of body composition. So this is what that group did. I would have collected all their data. They did all their measurements in private in the locker room where nobody could see. Nobody could see the results, and then I put them in. What we were talking about is going to go here, where you're going to go in, look at your experimental design, look at your data, see if your hypothesis was accepted or rejected. Did you get the results that you thought you were going to get? Why did you get the results that you got or didn't get? And how could you improve it? So this is your improvement plan. You're setting that up, you're graphing it out so that we'll have it for the template. And then the template you could even shoot the video. So you're shooting the video now, getting that taken care of so when we get on template day, it's already done. You haven't forgotten what you talked about on the first day of the week. And then once you have that, it's going to be put in to the template. But this is what you need for the lecture notes. Lecture notes will be turned in through Canvas, through the link. And then next class, we will start the template, and you'll already be ahead of the game. So I keep this lecture short on purpose to give more application time on this traditional lecture class so you can finish up your experiment, collect the data that you need, do the graph in class so I can walk around and help you. Since this is online, if you need any help, follow the model that I showed you. Keep it simple. And there's a lot of YouTube videos if you want to do something advanced, showing you how to graph out data on Excel or using Google Docs if you want to do it within Google Docs in their spreadsheet. There's a bunch of different methods, and I don't want to make this lecture super long. But that is it. We are done with the traditional lectures. Now we're going to move in after this into Project 2. Just like we did in Project 1, we're going to collect all those previous templates to build out Project 2. Once we finish it and do some editing, you'll turn that in. And then once we turn in Project 2, you're going to take Project 1 and Project 2 and build Project 3 from it. It'll give you the final stage of editing. I'll take that along with the cover photo that you've created and put it into your manuscript. And then the top cover photo that gets the most votes, and we'll have to do this online, will be the cover photo for your book. And I'll be able to give you an electronic copy of the manuscript probably around the 15th or 16th week. And then if you want a printed copy, you'll have to pay for print cost. You wouldn't be able to buy this online because it has your work in it, but I can get you a print copy that nobody else can purchase except for me, but you'll have to give me the cost, which I think it costs for this book, it's around $2.75 to $3 for print cost to get it done. But that's not required. If you want the electronic copy of the manuscript, I'll give that to you as well. But we'll talk about that in future lectures when we talk more about Project 2, Project 3, and how this is going to play out into a portfolio that you could use to get into a university if they ask for an example of student work, or maybe you're an art student and you want to showcase your skills and maybe your cover photo got selected for our book cover. Even if it doesn't get selected, all the group's cover photos will be in the manuscript and you can see the progression of them from Project 1, Project 2 to Project 3 if you've made improvements on them along the way. So I'm going to go ahead and end this lecture, and I will see you in the next one, which will be about Project 2.